Okay, this is just one type of example of finding the equation for a shifted parabola. Here's a horizontal parabola, which if it's not shifted is typically y squared equals the focal diameter times x. But this is shifted, so we know the equation of this is going to be, and the y and the x are both shifted, right? It's shifted down and it's shifted to the right. So you're going to have y plus or minus something squared equals the focal diameter times x plus or minus something, right? You're taking your y and x and you're shifting them. Now the x values here increase by 4. So that means you need a minus 4 here, right? Because you would have to put in a positive 4 to make this 0, and this is positive 4. And it's shifted down by 2, so the y values decrease by 2, so here you need a plus 2 built in to counteract the subtraction of 2, the minus 2. So we're almost completely done. We simply need our focal diameter. And the mistake that a lot of students make in this sort of problem is to assume that because this point here is emphasized, that the focus is in line with that point, and you don't want to assume that. I hope that this example doesn't put the focus right here so that we can see that the focus is not right there. We'll find out soon enough. What you need to do is look at this point as any random point on this graph and think of it as an ordered pair, 2, 0, since it's on the x-axis. 2 is x, y is 0, and now we need to substitute those values in to this equation for x and y. And let's call this unknown, because all we have to do is find this number here. Let's call it f. We know it's going to be a negative number because the graph opens to the left, but that should all fall out here. So I'm going to substitute 2 in for x and 0 in for y. So we have 0 plus 2 squared equals f times 2 minus 4. Well, 0 plus 2 is 2. 2 squared is 4, so we have 4 equals f times 2 minus 4 is negative 2. So f is 4 divided by negative 2, which is negative 2. So the equation for this graph is y plus 2 squared equals negative 2 times x minus 4. Okay? Now, the focal diameter is 2. That means the width of the parabola through the focus is 2. Now, if you think about that, the distance to the focus is 1/4 of that. So 2 divided by 4 is a half. So the focus is 1/2 unit away from this point. So you can see the focus is really like right here and not back here where we initially thought. Okay, so the focus is here, and the focal diameter in this case is 2. Sorry, I just had a student come in, so I kind of forgot where I was. I believe I was saying that this distance here to the focus is a half. The focal diameter is the distance of 2 total, so that means you go 1 up and you go 1 down, which tells you that this point is not, in fact, in line with the focus.